This was a weekly homework exercise of electromagnetic spectrum. Mention the questions in which you have doubt related to this exercise. There are two files I shared with you last week. One was exercise, another one was assignment. So first I'm discussing exercise of electromagnetic spectrum. Mention the question in which you have doubt. First in MCQs, any doubt in MCQs? Multiple choice question first. In question number 3, the violet bend more than the red. So why the violet bend more than the red? Because what happened when moving from air to glass, the speed changes for both light. As the speed of violet changes more than red, that's why the violet bends the most. So why does the dispersion occur when the white light enters a glass? So what is the reason of this dispersion? Because the speed of the violet light decreases more than the speed of red light. That's why it change its path or deviation occur. In question 5, which list show electromagnetic wave in order of increasing frequency? So the electromagnetic spectrum, we have radio waves, microwaves, infrared. The only part for which our eye sensitive, that is a visible. Then UV, ultraviolet, X-rays are there, and gamma. So moving from radio waves to gamma, what we observe the frequency increases. So which order is showing the increase in frequency? Visible, X-ray, and gamma, because you can see visible is there, then X-ray, and then gamma. That's why A is the right answer for this. Any other question in MCQs? Any doubt? Then the structure question. In a space below, draw a diagram to represent a sound wave. On your diagram, mark and label two successive compressions and two successive rarefaction. What are sound waves? Sound waves are longitudinal wave. Vibration of the particle is parallel to direction of the wave. So some region the particles are closer, that's called compression, and some regions the particles are away. We call that region as rarefaction. So then again there will be compression and rarefaction. Rarefaction means the particles are away and the pressure is low, and the compression means the particles are closer and the pressure is high. If you want to draw a parallel line, you can also use this method, but these are the wavefront. You can represent by the wavefronts as well. Like you can draw these lines. Region where these lines are closer, that's a compression, and the region where the lines are away, that is rarefaction. You can represent by these lines as well. Or you can draw or represent by the dots of compression and rate. So you both ways are acceptable. And then they say on your diagram, label, mark and label two successive compressions or two successive compression. These are, sorry, this one is a compression and the center one is a where the pressure is low, the particles are away. That's called a rarefaction. And wavelength. Wavelength is the distance between two successive compressions. So two successive compression or two successive rarefactions. That is called a wavelength or length of the wave. Then figure 7.1 shows a part of electromagnetic spectrum. On the figure 7.1, label the position for gamma, visible, and radio. So gamma, the highest one, so gamma is there. Then visible is between ultraviolet and ultra, but they did not ask to label ultraviolet, so visible will be here. And then they asked for radio, so radio will be after. After infra there is micro, and after micro there is radio. Which of these three types of wave have the lowest frequency? So lowest frequency, the radio is having the lowest frequency. And state the approximate value of speed of in air for radio waves. For all these electromagnetic waves, the approximate value in air is 3 exponent 8 meter per second. In vacuum, all travel with same speed, but in air, it is approximately 3 exponent 8, a slightly smaller as compared to that in vacuum, but we will consider as 3 exponent 8. In question 5, figure 7.1 shows a ray of a monochromatic red light in air incident on a glass block at an angle of incidence 50. What is meant by monochromatic light which is having a single wavelength or single frequency? That is called a monochromatic. For this red ray, a refractive index is 1.5 to calculate the angle of refraction. So it is moving from air to glass. So if it is moving from air to glass, moving from low density to high density medium. So formula for refractive index is equals to sine I over sine R. The refractive index is 1.52. Angle of incidence is given 50. And angle of refraction we don't know. Or sine R, when we cross multiply, sine R is equals to sine 50 divided by 1.52. What is the value for sine 50 divided by 1.52? Sine 50 divided by 1.52. 0.504, and then because you need an angle, so sine R is equals to 0.504, then take a sine inverse. So R is equals to sine inverse 0.504. So you will get about 30.3 or 30.2 degrees. The next, without measuring angles, use a ruler to draw an approximate path. So basically, when it moves from air to glass, it will bend towards the normal, but we don't have to measure. They already mentioned without measuring. And then again, if we draw the normal, moving from glass to air, it will bend away from normal, but keep in mind, for a rectangular glass block, the ray which incident and the ray which leave should be parallel to each other. Means the ray, this is a ray which is incident, and this one is a ray which leaves, so both should be parallel to each other. And this is without measurement, because already they mentioned you don't have to do the measurement, just sketch the path. The red light in figure 7.1 is replaced by a ray of a monochromatic violet light. For the violet light, the refractive index is 1.54. The speed of the light is 3 exponent 8. What is the speed of the violet in the glass block? So the formula for which relates the refractive index and speed. Refractive index is equals to speed in air divided by speed in a medium, which is here the medium is glass. Refractive index is given 1.54. Speed in air is 3 into 10 to the power 8. Speed in a medium is unknown, x. Cross multiply, so x is equals to 3 exponent 8 divided by 1.54. So basically, you can also solve in a short way. Just 3 divided by 1.54. It will be approximately 1.94, and the exponent 10 will remain. Exponent 8 will remain same. So 1.94 meter per second, or 1.95 because it is 948. So 1.95 into 10 to the power 8 meter per second. Use a ruler to draw an approximate path for the violet ray in the glass block and emerge from the block. Make sure that this path is separated from a path of a red drawn in A3, and mark both parts for this path with letter mark both the parts of this path with letter V. So basically what happened, as we know, violet is having a higher frequency. So if this was a path of the red, as we drew earlier, so this was a path which we draw for red. Now when we draw for violet, violet bends the most. But the ray which emerge out should be parallel. Is it clear? And we just have to label this as V. Any other doubt from this? Any other doubt from this exercise? Electromagnetic spectrum. This is exercise. Then there was a second file I shared with you, was assignment related to electromagnetic spectrum. Any doubt in this assignment of electromagnetic spectrum? And first in MCQs. MCQ 12. Okay. Look, radiation from the sun is dispersed by the prism. Basically what happened, the light which we can see, as we know the electromagnetic spectrum, we have radio waves, then we have microwaves, then we have infrared, then visible, and the visible include violet, indigo, blue, green, yellow, orange, and red, Vigor. Then UV is there, X-ray is there, and gamma. The radiations from the sun. So sun is giving UV also, sun is giving infrared as well, heat radiation. But what happened, the one which is having the highest frequency will bend the most. So, and visible also. Visible include violet, indigo, blue, green, yellow, orange, and red. So you can see as it passes, so violet bends the most, red bend the least in terms of visible. But what will be below the violet? So below the violet will be ultraviolet. Why ultraviolet? Because ultraviolet is having the highest frequency, so it will bend more. But ultraviolet is there, but we are not able to see ultraviolet or UV. Why? Because it is not in a visible range, so we cannot see the ultraviolet radiation. And same thing what happened, infrared is having a smaller wavelength smaller frequency compared to red, so it will bend, but it will bend less. So which radiation will show a greater change in temperature? Infrared radiations are also known as heat radiation. And how we can detect heat radiation? We can use a thermometer. So in which position does the thermometer shows the greatest rise in temperature? So that is position A. Why position A? Because we will detect infrared radiation, and infrared radiation can be detected by a thermometer. Is it clear? Discussion? Then question 16. The table gives the common uses of three types of electromagnetic wave, which row correctly identify the waves. For satellite communication, we use a microwave. So we use microwave for satellite communication. Terrestrial communication means not satellite on the ground or land. We use radio waves. And in a remote control, we use infrared radiation. That's why B is the correct answer, because the microwaves are able to pass through the atmosphere. So we can use a satellite to reroute them and can be detected to any other place or location. Any other doubt in MCQs? Then there is question. Any other doubt? 2A, C, D. Okay. Circle two of the following that apply to ultrasound. Ultrasounds are sound waves, but they are having a higher frequency, because the audible frequency range a normal human ear can detect, our ear can detect from 20 hertz to 20,000 hertz. So this is a detectable sound, but the sound which is having a frequency higher than 20,000, that is called ultrasound. And the sound which is having a frequency less than 20 hertz is called infrasound. Ultra here refers to high. So frequency, it's not in audible. So which one of them is not? 3.5 is there? It's not an ultrasound. 350 is an audible range, so this cannot be. Frequency more than 20,000, any value which is more than 20,000. So frequency can be 35,000, 21,000, 22,000, but any value above 20,000 is refers to ultrasound. And sound waves, all the sound waves are longitudinal. The particle vibrate parallel to direction of the wave. Is it clear, the A part? Then calculate the wavelength in vacuum for X-rays, which are having a frequency 1.3 exponent 17. So how to calculate frequency? V is equals to F lambda. The speed of the wave is denoted by V, frequency multiplied by wavelength. So we have the frequency and the speed. What is the speed of these waves? That is 3 into 10 to the power 8. So you will just substitute the value. So it will be 3 into 10 to the power 8 is equals to frequency 1.3 into 10 to the power 17 multiplied by wavelength. So this is multiplied, other side it will divide. So it will be 3 into 10 to the power 8 divided by 1.3 into 10 to the power 17. You will get the wavelength, that will be in meters. In the next question, a dentist takes an X-ray photograph of a patient teeth. Explain why it is safe for the patient to be close to the source of X-ray, but the dentist must be stand away from the source. Look, a dentist is taking the X-ray. A patient is only like for one time he's exposed to X-ray for a short time, but because a dentist, he's examining different patients and maybe he's taking 5 X-rays per day or 10 X-rays per day. So long-term exposure of, like, if a person body is exposed to X-ray for a long period of a time, it is dangerous for the body. So that is the reason when you mention like why for question number 2C. So for a patient, why it is not like for a patient, he's exposed to X-ray for a short time, that's why it is not harmful for him. But for doctor, because he's exposed, like when taking the X-ray, he's exposed to X-rays and longer period of a time, that's why it will be dangerous for him. Is it clear? that for the patient exposed to X-ray, for short period and small dose, which is not harmful. But for doctor, exposed continuously, so it will be harmful for him. Is it clear? Then for part D, the microwaves are designed to work only when the doors of this microwave are closed. So what is the reason? So state with the reason why microwave oven are designed only to work with the door closed. So these radiations, if a person or human body is exposed to radiation, these radiations are harmful. So when doors are closed, for microwave oven, microwaves cannot leave the because otherwise so when door is closed for microwave oven, microwaves cannot leave the oven. Otherwise, what happens? These microwaves are dangerous or harmful for human body. Any other question? In question 5, student draw a diagram to represent the electromagnetic spectrum. Figure 8.1 is a student diagram. Gamma rays, X-rays, ultrasound radiation, infrared, microwave, earthquake waves. The student has made two mistakes. On a figure 8.1, cross out the wrong and correct them. So what are the two mistakes here? Gamma, X-ray, this is not ultrasound, this is ultraviolet, UV. Then visible infra micro, and then it's not earthquake, it is radio. Any other question or a doubt related to this assignment, electromagnetic spectrum? Is there any doubt? Assignment, electromagnetic spectrum.